DT11 student, welcome to the topic called psychology of everyday things. Give it to the human mind the slightest clue and it goes off trying to find an explanation, rationalization and understanding. That's how human mind works. You close your keep a blindfold on eyes and give some object to the human beings. The inquisitive mind, the human mind tries to observe it with the help of hands, will try to smell, will try to identify shape, will try to bite it, take a taste of it, would feel its texture and would try to identify it. So we'll find some rationalization, some explanation. Human mind is very inquisitive. So the psychology of everyday things, so in short it is called as poet by Donald Norman. So Donald Norman is a very famous writer. So paperback copy of the book is available called as a design of everyday things. And the design of everyday object illustrates the problems faced by designers of computer system. So examples doors, digital watches, washing machines, telephones, and explains mental models and resulting design guidelines. So this entire presentation is taken from the book of Dr. Don Norman. So the short form is Don. It is Donald Norman. So we'll continue with this discussion. So it's very interesting topic. So mental model, what is mental model? Mental representation of how object works and how interface controls affect it. So people have preconceived models that you may not be able to change. Infix versus postfix calculators, dragging to trash deletes, turning a knob and opening things, right? So user interface which conveys the design model should match the user's mental model. Often we end up doing the correct things, but sometimes we go wrong because we have our own mental model of how things are operating and how things are working, right? So we need to identify these all models, different types of models, and how does it work. Okay, so this is how the design model and user model looks like. So design model is and the user model. So system user UI, that is the system user interface, is the middle layer or the middle thing between both of them. So user gets model from their background experience and the design elements of UI. What if the design and user model do not match? For example, if you are habitual of driving some, let's say, Maruti Suzuki's four-wheeler, and you know how that things work. So what is the difference between Maruti's four-wheeler and the Hyundai's four-wheeler is that the when you want to start the wiper and you want to start the indicator, so these two knobs are available on the rod. And when you are driving Maruti four-wheeler, it is exactly ulta. So when you are driving the Hyundai, so you end up, you want to give the indicator and you end up turning the wiper instead. So this happens. So what we say that the user is able to use that, still drive that four-wheeler nicely irrespective of whichever company it belongs to based on the previous experience. So what if design and user mental models do not match? And when they don't match, so what user expects to happen and to do, and when the things do not work like that, then there is mismatch, and the user ends up not able to use the system to the fullest of its extent. So design of everyday things says that many so-called human errors are actually errors in the design. Human factors became important as human performance limitations when reach handling the complex machineries. So how we are going to study this psychology of everyday things, or how does this design factor or things happen? So you'll soon know how these important concepts of designing things like this. So we say that perceived affordances, we are going to see some discussion on causality, visible constraint mapping, transfer effect, IDOMs, conceptual models, individual differences, and why design is hard. This entire discussion is taken by a slide deck by Saul Greenberg. You can see the permissions written at the bottom of this thing. So what is perceived affordance? So the perceived properties of the object that suggest how one could use it. So chairs are meant for sitting and tables for placing things on, right? So this is, do you know that the carpenter who makes it, he has not gone to maybe any school to understand it. He has worked under some senior carpenter and started understanding how to design things from his based of his experience. So no official schooling must have been done to do this, but based on the experience, user experience, भैया इसको और ऊंचा चाहिए, इसको नीचा चाहिए, मुझे ऐसा चाहिए, वैसा चाहिए, this person has understood the experience of it. Then on the right hand side image you can see knobs are for turning. So we have learned, as I have said I think in the earlier videos also, the knobs, how the knobs have come and what is the importance of it. Slots are for inserting, handles are for turning. So we can see that slots, and with this buttons are meant for pressing. switches for toggling, and computers for usage of doing some interactive work. So what is this? Why we are seeing these images? This is called as perceived affordance. A perceived affordance is a concept or is a terminology that when you see something, you understand what is it, what does it mean, and what it belongs to. Okay, so this is what we call perceived affordance. Now when a user is going to come across some new thing, so user definitely is going to have its mental model and would understand, okay, is I would do this so that it will do like this. And if that mental model or that experimentation, that concept is not matched with actual result, then user is afraid of using the system and may not use it and would say this is बहुत difficult to use करने को, I will not use it. So it's really difficult to use. So that's how the things happen. Second part is making things available or making things visible. Affordances: physical properties, shape, texture, color, etc. of an object that show functionality. So appearance indicates how the object should be used without the need for words, label, instructions. So that's what we call real life objects. And when they come into your real life, so they should have that you know kind of thing, or correlation of the outside world. So complex things may need explaining, but simple things, they should not need explanation. So gas cap, good or bad affordance. So how does it work? So what is good cap and what is bad cap? So how do you open it? So if you happen to take your car to refuel it, and so you definitely should know that it does not open from the outside. So there is a knob at almost at the leg room, at the leg place, with the driver's seat. You need to pull that knob, and that's how this door cap opens. So if you are not aware of it, you might end up putting the key hole, the sharper objects, just to make it tap it open, or some things. So have you come across such things that if you have such conceptual model, even it's not always same. If you see that if there are glass hand doors to something and it has got no handle to push or pull, so there is no handle, so what should you do with that? So either they must be sliders that you can slide it, like we have aluminum windows in your home with glasses, or otherwise these are the push things that you need to push the bottom of that glass door, and it gets pushed, and then it comes out and gets pulled. So that's how the object or things should work. So that's what we call. So these are good affordances or bad affordances, sometimes difficult to use. So elevator buttons, we have already seen an example. Please look at this image. So I got to go. So good or bad affordances. So on the blue arrow shows that this, and there is a small chit written which is magnified on the right hand side. This is a mop sink. So this is a mop sink where you put the mop after usage and something like that. So you should not end up considering it to be a basin kind of thing, right? So you have to make people understand and tell, because the shape itself is self-explanatory. So how do you open the washer and the dry doors? So definitely the left hand side washing machine shows that how it opens, and the right hand side is very easy to understand that how it is supposed to open, right? Now the problem is, if you want to do some key press, when the right hand side washing machine, the door is lifted, so you are not able to see the buttons at all, right? So you may want to do some change settings, then you have to again drop it down and then do it. So this washer, good or bad? So how do you put the same thing that I was explaining? So go back. Was this supposed to open it like this? So if you have this kind of opening, how does it work? The shape shows on the left top is that it is going to get from top to bottom. So pursuit affordances, this is a very famous example that you must have seen always. So product design, so you understand what it does. So pursuit affordance, you know where to put slide, where do you keep it, and how do you project it. So mirrors are not meant for touching, the knobs for turning, the handles are for lifting, and the surface for placing transparencies. So you know what you do. So you also get it, because nobody need to teach you. When you see a knob, you know that it is going to get rotated, you need to hold it, and you need to do that. So when you see certain shapes, so we understand it. So we call it as perceived affordances from the outside world. So there are issues like when mirrors are not for touching, you are not supposed to touch it, so people don't reposition the image. So instead of repositioning the image, they end up touching the mirror part, right? So So there is again some the small part over here. So what is it about? So people will not understand if they are not able to make certain settings, so they would definitely is going to touch it and might change the settings for altogether. So perceived affordances, GUI design. So here you can see those knobs, here you can see all those buttons. So perception only through visuals. Designer create appropriate visual affordances via familiar items and metaphors. So you can see dial for turning on the right top, right? So you know that how, where is it turning, the sliders for sliding. So if you naturally, if you raise it, if you raise the level, it is going to go high, and if you raise it low, it is going to go low. So music console for controlling the music, right? Now there are some separate buttons and these separate things. So buttons for pressing, but action is unknown. So on the right top, so is this equalizer, controller, or a toggle button? So things come with so much features that user should need to be either aware, or you need to bring these items or things or perceived affordances from the real world. So this is a typical perceived affordance problem. So is this a graphic control, is this a button for pressing, dial number? So you can come across many such examples like that. So we have seen this cup holder example earlier. Now we'll come to the another topic called as visible constraint. So what you see, so it is going to get constrained like that. So these are two separate images. You can see there is a lock and key, and the other one is a female and male connector. So limitations of the actions possible perceived from objects appearance provides people with range of usage possibility. So it's very easy. So on the left hand side key, so you may not, it's not going to have a problematic usage because you know how to hold it and how to insert it and how to use it, right? So similarly, the male and female connector available over here, so you cannot make a mistake because it is going to exactly go to the exact position where it is supposed to go. Now we'll come across the next image shows that is it push or pull. So I want your answer. What would you do, whether it is push or pull? So does the door handle, the knob, says what is it? Now this side, this is another type of knob or another type of handle which is going to open. So which side it is going to get open? Are you going to push it or are you going to pull it? Now is this door handle, is it clearly visible? So you can only push, and side to push visible clear. So which side you are going to push, it is visible. So when you see such kind of thing, so you call, you don't need to bother. Okay, so here you can always see that when such kind of door knobs are there, it generally it is meant for pulling. You need to pull it towards yourself, to the side this knob is available. Now what if the knob is available on both the sides? It is usually, so what does it mean? So again, it is a big problem. So if there is a knob contains only from one side, then it is understandable, right? So it is really difficult sometimes to understand, and this usually happens with the door handles. Cutting knife, which side to use? Just take a look at it. So which way should I go? Good or bad? Crucial distinction. So very interesting. The right arrow says that you are supposed to go to right, but at the same time it says that do not go. Does the uh, intender mean to say do not go to right hand side? Because it has got two ways, right? The left and right. So does it mean that you don't go to the left hand side and you should take the right side, or does it say that you should not go to the right hand side, right? So good or bad design. Gas tank and trunk release. So do you want to open the back side of your four-wheeler, or you want to open the fuel part? So if you happen to hit something, press some other wrong button, and you go to the back side to open the cabin, the section where you put your luggage, and you keep holding it, and you give you a lot of strength to open it, and by mistake you have actually opened the fuel tank, right? So which light is mine? This generally doesn't happen in India, and even if happens, most of the time people actually, it is so many signals, nobody would bother. Even if there is one signal, nobody bothers, right? So still, in many other countries where the laws are really strict for violation of rules, so people literally follow the deadlines and follow the things. So even if it is 3 a.m. in the morning, and if there is nobody on the road, and if you have got a red signal, you got a wait, means you got a wait till it becomes turns green. So that's how people use it. So when there is so many signals, and if it is not considered, so it's really confusing sometimes. So visible constraint, entering a date. So if you happen to give the form 1 as the thing where user is supposed to enter the date like May when typing the day and then year, so it's really sometimes difficult. So at the same time, you can see at the bottom, so People would month day year and month day year. You can see on the left hand side three different ways to do that. Against on the right side window where appointment is written, so you have got a calendar and you can select the calendar. From calendar it is really easy to select and it is not going to give me any errors also. This is a typical gas burner. Normally in India we do not have such system, but nowadays you will find in most of the homes such kind of burners too. So we'll see what is it all about. It's this we are talking about, right? So it has got four burners and you can use four different things at a time. You can use these burners to cook food. But now what is the problem? Now the problem is, since if you have a bigger pot in the front side, so it is difficult to access the back side pot, so it is difficult. So this is not only one type of difficult design. You will always find that it looks like the burner which is on the front side is bigger in size and shape, so you end up putting bigger vessels, bigger pots, and the smaller ones are going to take the back seat. Moreover, if you want four burners are in action and you want to now switch off one of them, so how do you switch off? So if you can see on the top, so you will find these buttons written, and the buttons, so red, black, 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 you can find, and the combination is shown over there if you can see it not properly. So it shows the selection. So the left, the red dot is going to show that it is the combination of maybe the positioning of this gas burner stove. So you will find that it is the left rear side, right, and then left front side, then right rear side and right front side. So it is, you need to either mug it up, otherwise you will end up, you want to turn down something, some one particular stove, and you end up something else, and so you're not going to create disaster sometimes. So this is how it is going to looking like, right? So hot plates, so this is the way this combination is shown over here. So it's really difficult to understand, right? So what could have been the easier way to do that? So if you can see that on the, if you turn it left it is going to go high, if you turn it right it is going to go low. So that's understandable, left and right, low and high, so it's acceptable. But which button is which, for meant for which particular thing, right? So it's difficult sometimes to handle. So we call it as mapping. You have to map this certain types, and many such problems you will come across if you have visited PICT library, the reading hall reading section. So you want to turn off some particular yeah, fan which is placed at the ceiling above you exactly, and you want to go and switch it off. So when you go to that switchboard, you will find almost some more than 50 buttons for the tube lights and fans, and now you have to do experimentation which one to switch it off. तो कैसा करोगे, कैसे कैसे करोगे? So you have to apply logic and you have to apply this mapping. So given this problem to you as, let's say, as an assignment, that how do you do that? So when I give this problem every year to students, so they come up with different ideas, and the general ideas is like many such ideas. Why I should tell you? I would be expecting some designs from you, right? So mapping the set of possible relations between objects. So control, display, compatibility, the natural relationship between controls and displays. So visual mapping of stores controls to the elements. So this could be one. So this is an arbitrary design. You can see the gas burners over here, and then back left, front back right, front left, back left, and front right. So 24 possibilities required, right? So this is the paired one, so two possibilities per side, so four total possibilities, right? Two left and two right. So this is full mapping, you can see. So these are the different ways how it can be arranged, and you can see that this is called as full mapping. The earlier one is arbitrary, so there is no relation. Second one is paired, so these two are meant for these two. The right side twos are meant for right side two. So again there is two possibilities per side, so four possibility. But here the way burners are arranged, the stove buttons are arranged, so it is made called as exact mapping. Similarly here also. So control, visibility, compatibility, right? So when you turn left the steering, that it is supposed to turn left, so it is understandable. So scroll bar scroll down, viewport goes down, right? So you understand that I'm doing this, so it is supposed to do that. So cause and effect we call. So this is called as mapping. So why mapping is really important? So selected picture, others are grayed out. So when you have selected something, and what can be done maximum is that all those things which are possible to do with certain image, only those are only active, and rest all are made inactive. So we call it as palette control. So you must have observed it in the PowerPoint presentation, or maybe anywhere whenever you are going to prepare. Actions. So cursor reinforces the selection of current item. So you can see that the way it is drawing, so the same cursor and the left hand side, the depress button indicates the current mapped item. So the item being selected and the actual on the screen looks same, so it shows that what kind of item is being selected. That's what we call mapping, is really important, and we call it as action feedback. Interesting problems, mapping problem. Quick, open the top drawer if you are in really hurry. So this is the, you can see that the white arrow is indicating to the handle of the drawer to be pulled. An affordance handle is for pulling. Mapping suggests it should be open the drawer, but it does not. Right? So this is only meant for moving the drawer from one room or one place to another place. Maybe this is just a metal rod whereby the drawer has got its own bracket where you need to put your fingers and pull it out, right? So mapping suggests that it should open the drawer, but it does not, so it creates confusion. This is the common map ambiguous problem. So where, these are PS2 connections where you want to plug in your keyboard and mouse, and how do you do that? This you will always find in the backside of your earlier machines. Nowadays, now since all of them are USB, so you don't find this problem or this kind of difficulty. Okay, so we call it as and mapping is ambiguous, so you need to try it out. Unfortunately, the PS2 used to be having very delicate pins, so if you push it hard, there is a high possibility that you will end up losing, breaking the pin, and if one pin is broken, you cannot repair the pin. You need to throw the entire keyboard or mouse and buy another one. So causality, the thing that happens right after an action is assumed by people to be caused by that action. If you sneeze and somebody is blooming, it's only because of that dust. That's how we conclude. Interpretation of feedback. False causality. So incorrect feedback also sometimes. Invoking unfamiliar function just as computer hangs. So causes superstitious behavior. Whenever I swipe my fingers on the reward I received on Google Pay, I always get better luck next time. When my son does it, he always gets money. So I can be superstitious anywhere, right? People are generally superstitious at any point of time. If you happen to drink tea when Dhoni is batting, so there is a possibility that he would get out. So we have some kind of superstitious behaviors, and we have some certain causality of it. So invisible effect, command with no apparent result often re-entered repeatedly. For example, mouse click to raise menu on an unresponsive system. So people normally have got this habit of doing it. So invisible effect is really most of the times really dangerous. Why is it dangerous? Because it has to do with the effect. When I switch on my machine, and if my machine is heavily loaded, I just see the desktop and I want to double click onto some icon to open, let's say Microsoft Word. I want to type a document, and what I did, I just took my mouse pointer, double clicked, and nothing happened. So I felt that my mouse is not connected properly to the system. So I unplugged it, and again I plugged it. Meantime, my machine is heavily loaded, and it is trying to load everything into the RAM and getting the system ready for to accept your response. But since it didn't show me the message, or it did not tell me that it is processing, there is no sand clock, maybe it is showing. So what happens, I understand that there is some problem with my mouse. Then what I will do, I will right click on the screen to refresh, because we understand as we get freshed or refreshed in the evening, right, we go to the wash basin and put water on your face getting ready. So like that, people use the right click of refresh to machine ko refresh karna hai. Machine is heavily loaded, right? So there is already one command on stack that you double click Microsoft Word. Now you are expecting it to refresh. Now you feel that something has gone wrong, and then you give the third Control Alt or Delete, that you want to go to Task Manager and see what is happening with it. So you have, so now meantime it is processing the first action. Now you have second action of refreshing already came. Now the third action has also come in the form of Alt Control Delete. So now it is doing Alt Control Delete. It is expecting you to you are expecting that the task manager to open. So like this you have, and when nothing happens, you end up pressing reset button. So the machine, the same story repeats. So important, what is important is feedback, and that too feedback is interpretation of feedback is really important. Now we can see effect of visible only after execute button is pressed. So OK does nothing. So now let's say this is an example. So this is the house, you want to color it with some particular thing. So RGB is given red, green and blue. So the range is 0 to 255. So this is 3. So this is 24-bit image. So it is like 65536 color combinations possible, right? So that's a BMP image that is maybe getting generated out of it. That's what we should conclude. So if you set some RGB value and press OK, nothing is happening as long as you don't press execute. It is same concept like OK, cancel, apply. So the effect won't be seen as long as you press the apply button. You must have come across this problem in earlier Microsoft Word. Let's say you have written a paragraph and you want to change the font. So how you change the font? You select the paragraph and then you change from the font size from 14 to 16. You click from 14 to 16 and then you see the effect. ओ छोटा हो गया, फिर 16 से डायरेक्टली आई विल डू 20, ओ ये तो बहुत बड़ा हो गया, फिर देन आई विल डू 18. सो I have to do click it and then see. So how the interfaces become smarter and user interface is really changing nowadays. If you scroll over your mouse to the size of that particular thing, you will see that it is getting changed automatically. So cause causality problem. So you press OK, nothing happens as long as you don't press the execute button. So people transfer their learning expectations of similar object to the current object. So position positive transfer, people previous learnings also apply to new situation. So negative transfer, previous learning conflicts with the new situation. So it is sometimes really difficult to learn something when you know some earlier knowledge, and at the same time when you have knowledge it is really difficult to unlearn something. So this is called as transfer effect. We can have many such examples. Let's say you have recently changed your residence and now you have often used to go to your, since now maybe a few days back you have changed your residence. It also happens that when you are thinking and you are driving, walking, you end up going to your older house, right? Sometimes it is really, so that is called as transfer effect. We don't remember because our mental model is set for doing that particular thing. Most of the time when we drive, actually our conscious mind is not working, it is all subconscious mind. So if you are driving for hours together, you have got onto an autopilot mode system of your brain that you just watch for obstacles and then you keep driving and you keep thinking something else. So your mind is continuously just observing the road, the obstacles, and like that. So our mind is really very complicated. Negative transfer, previous learning conflict with the new situation. So whatever you have learned earlier, it's really difficult to unlearn. So we always come across this problem. If you have learned, you are using some SIM card and some mobile number, proudly ये मेरा number है, and then you have suddenly changed your SIM card and your contact number, new number, and now it is really difficult for you to mug the new number. So when you do it, it's after a few days it is really difficult for you to identify or remember your earlier number, right? You don't remember your earlier telephone number. Why? Because it has completely gone out. So human brain is very complicated. So this is called as transfer of effects. Transfer of effects problem. Transfer of effect problems, you can find a lot of things. We have seen items and population stereotypes in earlier things. We have discussed this is called as cultural association. So this is on the left hand side, you can see the Apple paint facility, and the right hand side is Windows typical paint facility. You can see that they have maintained the synchronous part, so that there is heading and then the file edit, and then the words are almost same. On the left hand side, palette is there, the options are there, and at the bottom the colors are there, so they look same, right? So people have mental models on how things work, built from affordances, causality, constraint, mapping, positive transfer, population stereotypes, cultural standards, instructions, and iterations. So models allow people to mentally simulate operation of device. Models may be wrong, particularly if above attributes are misleading. So human brain, the mental models that are being designed are always most of the time correct. A funny picture. How do you pour? It's a good example of scissors. So when you hold the scissor, it shows that which finger should go in which hole and how does it work. So it has got correct affordance, holes for something to be inserted, constant big holes for several fingers, and small hole for a thumb. So it won't accept more than one thumb at a time. So really good mapping between holes and fingers suggested the constraint by appearance, that what it is supposed to do. Positive transfer and cultural items learned when young, and constant mechanism even if you have learned it before 40 years, right? So conceptual model, implications clear on how operating part works. So when you have this spinning and when you move your fingers, automatically the part rotates. So it's really good example of scissors. A bad example of digital watch. Just go through it. So affordance, 4 push buttons to push, but not clear on what will they do. So constraint and mapping unknown. So it's really difficult sometimes to do this activity or action with reference to this. Transfer of training, it's very little. We say that little relation to the analog watches that happens, and the cultural items somewhat standardized core controls and functions, but still highly variable. So conceptual model must be learned. So designing a good conceptual model, so design model, users model, and systems. So there is system in here. So all work together to remind a person of what can be done and how it can be done. How do you design for it? So there is one person who is too tall, the other one is too short. If you can see these three images and there is a mirror and all of them want to see that, so how do you design for it, right? It's difficult sometimes. Same thing happens that if the person, the doors are designed for an average height, if somebody comes too tall then it is really difficult for that person to use it. Who do you design for? People are different. Then there is rule of thumb, cater to 95% of the audience, the fifth or the 95th percentile. But it means that 5% of population may be seriously compromised. So yes, definitely you cannot design anything for them. So cars and height, so headrooms and seat size, so it is an average, right? So we people always do it, go for average things. So these are the few slides of why we say that why it is important, very important to learn. So based on these things we can consider why designing is hard. People consider cost and appearance over design. So most of the people really buy some products even if they are not handy, they are not useful, and based on their appearance, and you know that over the design part, that what goes into design, how usable it is going to be. So people really don't care sometimes most about it. So people tend to blame themselves when error occur. I was never very good with machines. I knew I should have read the manual. Look at that, I did I feel stupid? So you know, people blame themselves instead of they blaming the design that is being made for them. So the new wave of cheap telephones accidentally hangs up when button hit with chin, you know, bad audio feedback. So you must have come across these all kind of cheap systems, cheap mobile phones where not quality hardware and software is involved as a part of process. So human factors in computing system, what does this do? So computers far more complex to control than everyday devices, definitely. So general purpose use of computer contains no natural conceptual model. You just look at this machine and you it can do a lot of things, but you should know how you need to get it done. So completely up to the designer to craft a conceptual model. So this is how we'll end up our discussion on the psychology of everyday things. What you know now is many human errors are actual errors in design, so don't blame the users. So you got a designers help by providing a good conceptual model, affordances, causality, constraint, mapping, positive, transparent, population, stereotypes, and add-ons. These we have seen in this presentation. So design to accommodate individual differences, decide on the range of users, and design is difficult for reasons that go beyond design. So design is really difficult for reasons that go beyond design. So when the reasons are not limited to the design part, so it's really difficult in that some situations. So T11 guys, I hopefully hope you that you know you must have understood some concepts of psychology of everyday things. For more information, you can visit Don Norman's website, book, and many such images you will always find. So happy learning. See you in the remaining part of this unit number 1. Thank you very much.